Hey, good morning, guys. Hello, good morning. Hello.
Morning,
How,
Neeraj.
how are you doing?
Good, good. Neeraj, one thing, that virtual machine and the container thing, if you can do just a quick refresher on that.
Okay, no worries. I'll do that. Yeah, I'll do that right away as soon as we start. I think, yeah, it is good to understand those differences because we'll do a lot more containers. The world is moving towards containers and not so much into VMs anymore, although VMs are still useful, but eventually, you will see that containers are going to take over in terms of the usage model. So we have 3 people right now. Who else is here? Let's see. My cable connection is broken. We'll fix that. Okay. Let's see who is here. Dennis and Mukesh. That's it. Hey, Dennis, can you hear me? He said,
Loud and clear.
yeah, good. So I saw that you attempted to join at like 7:30 in the morning. I got a notification saying somebody's waiting on the Zoom call.
Oh yeah, just
Yeah, you
launched
probably
it.
clicked and tested or something, so that must
Oh yeah, I just launched it and then also listen to other websites.
right. So that notifications come into email saying Dennis is waiting. And I said, you know what? He must be testing or something like that. You're causing a lot of noise. You're capturing a lot of noise through your microphone or something.
I'm gonna mute.
So maybe you want to adjust your microphone or maybe remove and plug it again. That will fix the problem. Or you can mute, of course, but it is noise. It is static noise generated by electrical signal in the microphone. That's what's going on. So you may want to remove and put it back in if you have an external microphone. That should fix the problem. Cool. So I think other people are probably sleeping. It is too early in the morning Saturday. So it is just 3 of us, I guess. So we should focus on what you want to talk and then maybe wait for them to join, wait for others to join. So I should begin. Mukesh had this question about, can we cover a little bit on understanding this concept of what he wanted to get a quick refresher was on this topic of VM versus container. So VM is, think of it like this. It's a place for applications. And this thing is a place for operating system plus dependencies plus applications. It contains a lot more things than just the application. That's how you should think about it. Whereas this is strictly a place for applications. These elements are almost redundant. And so you basically cut them in this example. You reuse. That's the core concept. So you want to make a place for applications to live, you create a container. And if you want to create a place for entire operating system, dependencies, and applications, all of these things you put a VM. And so the same idea, you extend it and say, you know what, I want to have Windows operating system, and then I want to use .NET application environment, and then I will write my own app. And so these are the three layers: operating system, dependency, and then your application. And that is necessary for your app to run. This app will not run without .NET, will not run without the operating system known as Windows. And so if you want to run this particular app, you have to have Windows. And this is the reason why you cannot run an app that uses .NET and Windows in Docker. Because Docker today supports Ubuntu, or rather Linux in general, not Windows. So you have to have a place for all of these things. And the only way to get this to run is in a real computer or a virtual computer. But if you try to put this application only, just this app, inside a container that has Docker, the Linux Docker built in, then it will not run, because the underlying things that are provided to the application from the foundation up are missing Windows. Cannot have Windows there. You cannot, as a consequence, you cannot have .NET there unless you are running some open source .NET known as Mono, which runs on Linux. And then it doesn't require Windows. In that case, this is an open source .NET implementation.
I thought actually Microsoft bought it, right?
Sorry, say it again.
For the Monarch, I thought the Microsoft, in some ways they bought it, with the companies that do the development tools.
I think Mono is an open source project all along. It is
Simon, yeah, how do you pronounce it? The companies that do the cross too.
I think you're referring to this company.
Yes.
Xamarin.
Yeah, I think they bought it, right?
Yeah, they bought this. Microsoft bought this thing. So this is your applications that are creating .NET based applications, but using the underlying Apple operating systems, such as iOS in this example, and you write in C#. And maybe you write an Objective-C or Swift or Java, whatever you do in these languages, you can do it in C#. If you are a C# developer, in that case, it is totally useful for you to continue leveraging whatever your skill set is. So, you want to, if you are, you have ton of experience in this language, but these other platforms like iOS or Mac OS, these guys require you to learn, say, Objective-C, or the other language called Swift, or those languages. You may not want to learn because you already know this. So you want to write your programs in this language, and you want to run them here or here. In that case, you need a tool like Xamarin, which will basically provide you a .NET environment on top of these operating systems. And so this Mono project that I'm referring to, MONO, is very similar, except it is open source. And it will let you run your C#.NET programs on top of wherever Mono runs, so on Linux, for example. In that case, it will work. And yes, you can have this running in a container, provided you have Linux underneath, and then open source applications as intermediate dependencies, and then your app. That will work. If you try to run your app and don't have Windows under the hood, you cannot put that in the container. That's the core idea. Now, let's go a little bit deeper. And let's see who else is available right now. So we have 4 people, it seems. Ram, hey Ram, how are you doing? So
good, thanks.
Sure. Mukesh had this question about briefly go into distinction between containers and virtual machines. That's what I'm quickly doing before we start the new session, which is the session for today, starting Cloud DevOps. So that's the discussion I would like to have. But just closing out on this short discussion, and we'll go more at various times as needed, is this idea where you take a big computer, like I showed you in this example. Let's go take it again. So here is a machine. So this is the Macintosh. And in this Macintosh, you have, a processor with 4 gigahertz Intel Core i7 and 32 gigs of memory and some storage here. And so these some hard disks available, some display and all that, right? So we have 32 GB RAM, some storage, some displays connected, and your machine itself, the CPU is this. That's the kind of hardware characteristics we have right now in this. So we have this much of total, some huge amount of storage, and then 4 gigahertz of Core i7 CPU. This basically gives you 8 virtual CPUs. And so you want to then carve out a portion of this real computer. This is the real machine. And you carve out a portion and emulate the hardware. Emulate hardware. This is not simulate. No, emulate. Meaning exact machine level instructions will work on this portion. Exact machine instructions like you wanted to have. So you can have virtual everything, virtual CPU, virtual memory, virtual disk, virtual input, virtual display, virtual mouse, virtual keyboard, virtual every single thing. And that's what you see typically in a virtual machine. So the virtual machine, like you have here, you have these things like virtual base memory, virtual boot sequence, hard disk first, then optical disk, acceleration, VTX, AMD, nested paging, then physical address extensions, no execute bit, KVM para-virtualization. You have video memory, 128 MB, and you have some optical disk drive, which is empty. You can mount a disk image if you like, or there is a disk that I can mount if I want, but I have no need for it. So I'm just leaving it empty. There is a SATA controller. There is audio card, which I have disabled because I don't want to necessarily play music in the virtual machine, but I can enable it if I want to and say enable the audio. And then sound will play through the VM. I'm keeping it disabled. There is a network adapter. I can add more. 1, 2, 3, 4 adapters are possible. And similarly, if I can go USB, enable USB access, I get a USB controller. I can put USB 1.1, USB 2.0, USB 3.0, or things of that nature I can enable. Similarly, what you're looking at in this machine configuration is not something that is real, but this one is very real. So you can associate out of this 32 gigs of memory, you can allocate a portion of say 2048 MB of RAM and some portion of every single physical component that you want, and you emulate a complete set of hardware so that you can run exact CPU level instructions. At the virtual machine level, at this level, at the portion level, you can run exact CPU level instructions because every single component in the hardware is emulated, not simulated. There is a difference. The simulation doesn't mean it is for real. So simulation versus emulation. Let's go. I did not type properly. Emulation. And there we go. So here you can read what exactly is the difference between simulation and emulation. So you can go click on this and they'll tell you exactly what it is. So here, emulation is the process of mimicking the outwardly observable behavior to match an existing target. So it is basically making the exact machine look like a real machine, although it is not a real computer. So you're basically emulating hardware in virtualization. The internal state of the emulation mechanism does not have to accurately reflect the internal state of the target which is emulating. Simulation, on the other hand, involves modeling the underlying state of the target. The end result of a good simulation is that the simulation model will emulate the target which is simulating. I think you have to read it a couple of times to really get the concept clear. But in simple language, here is one more example, simpler. A virtual PC emulates a PC. That's a virtual machine, right? In a flight simulator, you could transport you from A to B, then it would become a flight emulator. So in a flight simulator, you go and sit in that funny vehicle in Disneyland. It doesn't actually go from A to B because it is simulating. It gives you the experiences of flying, but it doesn't actually travel. That's simulation. Whereas if it actually took you from A to B location, physically moves you, in that case, it becomes a flight emulator because it's actually a real flight. And that's the difference between simulation and this is a better example, I think. That's a very good one, good way to say. An emulator can replace the original for a real use. A simulator is a model for analysis. That's a very nicely described way. So I'm going to upvote it. That's a good way to describe. And so a virtual PC emulates a PC. In a flight simulator, you don't actually travel. You get all other experiences. So that's the simulation. It is in a virtual machine, you're basically emulating. It will actually function like a full computer. That leads to a virtual machine. You're getting a full computer. So you go to DigitalOcean, Rackspace, Amazon, Google, Microsoft, Azure, everywhere, you're basically getting a virtual machine, a full-fledged machine that is actually not real. It is a virtual machine. But it functions just like a real one. It will do whatever you want, throw an operating system of any sort, not just Linux. And it will take it. It will run it for you. And it will perform exactly what you intend to do because you're running byte level code, CPU instructions. You're running the real instructions at a hardware level. And that is what it is doing. Now that involves a little bit of overhead. The overhead is that you are running some CPU instructions on top of this virtualization software, which in turn is running on top of a real CPU. So that's the overhead. So it has this layer that you have to deal with. So it slows down a little bit. So that makes it a little slow. If you're running these instructions, this is the VM instruction set. So VM instructions, you're running it directly on the real hardware. Those will run a little bit faster because you are cutting down on this layer. Similarly, if you can take this commonality, so the real hardware, emulation software, which is basically known as virtualization software. And then you put your operating system. In some cases, like in our example right now, which I'm showing you, there is an operating system here also, which is the Mac operating system. And then this operating system is the Linux operating system. So you have double OSs already. And so in other cases, you may not have, like in the context of cloud machines, you don't have this. They run the direct emulation software directly on the real hardware, which is called virtualization software, or also known as hypervisor. That's what they're doing. They're cutting this underneath OS, like the Mac OS I have here. They cut that piece, so that's a good benefit. But you still have this emulation software to deal with, which makes it a little slow. Then you can put any OS, like Linux or Windows or whatever you want that runs on that hardware. And then you put your other things on top, like dependencies. And then you put your applications, and then your app runs. Now imagine a case where you can put the applications pretty much like this, except that you are reusing your real hardware. And it has a real operating system here, as long as it is Linux. And you can then put your dependencies here, another dependency here, another one here. And then you keep adding your applications. So let's say, for example, this application number 1 and application number 2, they both need this dependency. So they can then fit into segments like this. And they can reuse whatever else is under the hood. So application 1 can also use the same dependency that you have here, and the operating system that you have here, and the real hardware. And then you have more applications, say app number 3, that wants to use this dependency. Totally no problem. You can just divide like that. And another application number 4, that uses this dependency. You can totally create these containers, container number 1, container number 2, container number 3, and container number 4 for these 4 applications, 1, 2, 3, and 4. And so you're basically cutting down repetition here. You cut this, repeating this thing over and over for every application. In this context of virtualization, you have to basically get the emulation software going, then put your operating system, put your dependencies like this one, repeat that. You're cutting this burden because you can, because container technology gives you the ability to cut that burden. And that is why you see a very quick startup of a container, as quick as you saw. You basically let's see that. Where is that VM? Oh, I did not start it. Okay, virtual machine, and in that VM you can just click a command and it runs. So I can maybe connect to another computer instead of starting the VM. So here is a machine that I want to connect to, which has a bunch of technology already included. So in that machine, I have Docker already installed. I'm just connecting to that machine in the garage. What I'm going to do is show you here that I can start a container very, very efficiently. Docker run -it Ubuntu, and then I give me bash prompt there. And so it gives you, it doesn't have Ubuntu layer, so it brings it down, and then it pulls down that operating system, and then will give me this bash prompt, and there I have it. So since the image was not locally available, it took me some time to install that image, bring it from the Docker Hub, and now I have that image. So I quit. Now I can see that there is this dead container that exited 5 seconds ago. I can remove that container, basically saying rm-f and 0605, and it goes away. And then I can see that I have no containers and no dead containers, nothing else. I can now run the same command, Docker run it ubuntu bash, and watch it. In matter of milliseconds, you will have a new container ready and operating. Here we go. So it makes it super efficient. What is going on in this example that I just showed you? And we'll do more examples like this, essentially, over the time, is like, another operating system. You saw this before also, but I'm just doing it for the sake of example. This CentOS doesn't exist locally on that machine, so it is going to pull it down and then run that OS inside, and then build a new container and just start it immediately as soon as the thing runs. So here the container is ready. You can start another one, and it almost instantaneously gives me a CentOS container like this. And there it is. So in this example, what you just saw, these two examples, quick one, what you saw is on that machine, which is a big computer sitting in the garage, I have some Linux OS, and I have Docker capability installed here. The Docker engine is running here. That's it. I mean, there is no other thing on top. So it's a pure real machine, no virtual machines here, and it runs Linux, and it has Docker built in. And this Linux is, it's the only operating system sitting and running on that machine. I should write it in the middle like this. That's the OS. Now here I'm getting a terminal, and I say, please give me Ubuntu. So it gives me a container running Ubuntu OS. Give me a container running CentOS. So it gives me a running CentOS OS. And that's what the two things that you saw. Give me bash prompt as an application there. It gave you that bash prompt. And it took me milliseconds to start these guys. Like if I were to start a virtual machine, it takes me at least a minute or maybe 55 seconds, which is quite long compared to this. It's very quick to generate a machine, to kill it off, start another one, add more layers of things you need to go on top. And this layers that I'm talking about, 1, 2, 3, whatever I want to add, are basically layers of file system. Layer of file system. And you define these layers in a simple file known as Docker file. You define these layers. What do I want to have here in a file like this? So here in the example, I have this container running. I'm going to quit out of it. And now I will attempt to write a simple example of a Docker file. So let's go to a Docker file example. And here is a Docker file reference. So let us see a quick one. Okay, 1, 2, 3. A quick example I'm trying to find out which we can make use of. Here is a Windows example, by the way. So I'll translate that into a Unix example so we can run. I don't have Windows here. So I'll convert that into a Unix example and use it. So what you're looking at in that example is this. So line number 5 says, begin from Windows Server Core. And then says, copy this test file.txt into the C drive. And then make my running directory the C drive. That's what it says. So in our example, what we can do is change it. Instead of say from Windows Core, I'll say from Ubuntu. Or not in Hindi. Hold on, let me change my keyboard. Okay, there we go. Ubuntu. And then copy some file to the location, let's say /root. And that's it. Let's leave it at that. So very, very simple Docker file like this. 2 lines. I'm changing the line number 5 with one more thing. I'm creating a test file and putting that in the root folder. That's the only thing I'm doing as a layer. So line number 6 creates a new layer. And on top of the underlying Ubuntu OS. So here, this machine that you're looking at, which is a Linux machine, and there is no virtual machine directly accessing the VM. And what I'm looking at is creating a folder. Let's call it Mukesh. And then go in that folder. Go into that folder, and in there I will create a file called Docker file, like this. And in that file, I will put these 2 lines. No, not these lines, but these lines. And Once I have these two lines in the Docker file, what I will do is I'll build a new image. New image I will build out of this Docker file. So what this Docker file says, go get that Ubuntu image, please. And then in that image, copy this file. But that file doesn't exist. So I will create that file. And in that file, I will write something like, hello, Mukesh. And now in that file, we have this written down. So the file exists and the Docker file exists. The Docker file has from Ubuntu, and this item needs to be put inside the container. That's what we would like to have. And so what I would like to do is this test file needs to go in the root folder. And so that's how I would like this new image to be built. So that means something like I would like to build a new image, and I would like to call that image Mukesh. And so here, I'm going to build that image now. It is very simple. Just watch this. Docker build, and then give it a name. The name will be Cloud Genius Mukesh. And then build it using the folder, this one, dot. I mean, use this current folder to build a new image called Mukesh. And that's the image I'm building. Here it goes. It builds. It uses this Ubuntu base as the foundation, this line here, which is also the line number 5. And then the step number 2 is creating a new layer. In that new layer, I'm adding some dependency. The dependency in my example is going to be this file called testfile.txt, which contains this line called hello Mukesh. And that's a new layer I created. And you can see that this hash changed. And step number 2 creates a new hash for a new layer that contains this test file. So we have now a new container, a new image, Alpha Bravo 8 Delta. This image is the Mukesh image. Now let us see how many images we have. So we have a bunch of images, but watch this. This image, Alpha Bravo 8 Delta, was created 50 seconds ago, and it is 127.1 MB. If you compare this image with the Ubuntu image, it was created 4 days ago, and it is also very, very similar in size, 127.1 MB. Very similar in size here and here. The reason is they are almost identical except one line different, one file different actually. This file was added. So now I'm going to send this image to you, Mukesh, and all of you actually. So I'm going to send this image by pushing it to the Docker Hub. So I will say, Docker push my image, Cloud Genius Mukesh, to the Docker Hub. So it goes and sends it. It says I need to log in. So I'll log in, Docker login, and I will type in my username, and then I'll get my password and provide it to this guy. And then I'll copy my password and then paste it. So I logged in, and then I can send my image over to the Docker Hub. As soon as I finish sending, you should be able to pull this image on your machines and run it. And so I will do that right now. And I will also ask you to do that. So I'm going to say that, please pull this new image that I'm sending it right now. You should pull it, like line number 10, Docker pull. And when you pull this image, you're basically getting the Ubuntu image plus one change. And that one change is the test file that I I added through this line number 6. And then I build a new image. And I'm sending it over to Docker Hub. So we should be able to go to the Docker Hub and find out what do we have there in terms of images, and do we see this Mukesh image there now. So here we go to the Cloud Genius organization and search for Mukesh, and there we have it. So Mukesh is available, and that's the few seconds ago it was pushed. So you can pull it like this. So I'm going to pull it in that virtual machine. Where is that VM? And you should also pull, by the way. This push succeeded. The push succeeded. So that makes it useful. You can also push. So you can also pull right now. You can eventually push if you establish an account, which is free. And so you should absolutely create an account. And what I'm going to do now is pull that image down in this VM, this Cloud Genius workstation. And in there, I will look for that file called testfile.txt in the image. That's what I will do. So the machine starts. I'm going to now bring the image down, this Mukesh image, in that VM. So this is a virtual machine. And in here, I will say, please Docker pull Cloud Genius /Mukesh. Bring it down. So it is coming down from Docker Hub. And it says, I have it now. That's good. Now let us run it. So Docker run it, Cloud Genius, Mukesh. And give me the bash prompt in there. So it gives us. And let us go see whether we have the file called test file. It is there. And let us see what it says. It says, hello, Mukesh. And that is what we did. So I think that gives you a very clear idea of what the heck is going on in Docker. We created a file like this called Docker file. We also created a test file.txt that contains something silly like hello or some silly little thing just to demonstrate. So this file was there containing some text. And then we pushed that over we built an image first. So let's go write that down. Docker build -t for a name. And then we use this folder. This dot means that folder. Then we have an image ready. Then we have to push that image over to the Docker cloud. And then you pull it down. Then after you pull it on your machine, you pull it down. And then you Docker run. And then you see that inside that you go to this location, and then you see that we have that file called test file, and you cat and you see it.
So the tag Cloud Genius before the name Mukesh that you gave while you were building the image. So
Correct. That is the tag.
So that's merely to specify or to identify all your repositories.
Yes. Correct. So the tag is line number 13 -t tag. And in there, what happens is you have to basically specify that I'm going to send it to this account. So you might have multiple, like I have to send to this account or that account. So this Nilesh is me, and this is my organization. And so you have to create an account, create an organization if you like, or things of that nature. So you can create an organization, which is also free. You can, of course, create a login, which gives you a profile, and you can make use of it. And that name here needs to be specified. Once I take that name, nobody else can take that same name. So you cannot create a Cloud Genius Mukesh, but you can absolutely create Shahi Mukesh. Like, instead of Cloud Genius, you should say Shahi. And that will work, no problem. By the way, you just saw me do multi-line edits, which is possible in Atom Editor also. You just have to highlight a word and Control D multiple times to select all the occurrences of that word and just change. And that is super powerful. It is a capability in Atom and in Sublime, and a bunch of other modern editors have that. It's a beautiful thing.
So based when you created that image, it also created the container there as well, right?
A container is when you run it.
Okay.
When you run, that's when a container gets created. Line number 30 builds an image. Line number 15 pushes an image. Let's go write that down. So here, this is build an image.
Container is the runtime version of image.
Push the image. And this is on your machine. You're pulling the image. And here you are run a container using the image.
And as soon as you stop running, the container goes away.
The container dies. It has a dead body left over. You can see the dead body. I will show it to you. So hold on. There is a specific meaning to the word dead body, and I use that word. It's a made-up word. The proper word for it, I think, is exited container. So if I have this thing running right now, so Docker run it. So Docker run it is running that container based on this image right now. And that is the image highlighted here. And this is the container, Delta Brother 94. That's a container. If I exit from here, then I have a dead body. The dead body is also the same identifier as the container it was running, Delta Brother 94. Except that this is exited 4 seconds ago. But you still have the hard disk corresponding to that dead body in your machine. You have to get rid of it. The reason they leave this hard disk behind is because you may want to access its content. And so you can actually access the content of a dead container. It may be not running, but you can still go and extract whatever you want from that storage that this container used to have. And so that's if you have exited a container 4 seconds ago, you can still access the hard disk or the storage corresponding to that container.
And also you can restart this, right? Because
no. You can use the hard disk and start a new container. Hard disk, but no, you cannot restart the container. A container exited is dead, it's gone.
Okay. I thought because you have already downloaded, the contents are there, you should be able to restart. No.
Yes, you can restart, but you're not getting the same identifier.
Yeah, you will get a new ID. Okay.
Correct. Yeah, you can.
So, quick question. So let's say I ran the container and it is running, but by mistake, I shut down my VM, the VirtualBox VM.
Okay.
So when I bring it back up, so this would have been dead too, right?
Yes, except if you run it differently, like say dash daemon.
Is it daemon? Okay.
Daemon mode. So if you run the dash D option, and let it run, it will keep on running. So you have this number 4F94, that will be there. Let us go reboot. And go. So the 4F94, I'm going to reboot the VM, and you will see that the 4F94 survives after a reboot. It will keep running. And so we'll see that as soon as the machine reboots. And so in the Slack chat, what I'm going to do is create a snippet and just post my notes on the exercise we did. So I posted that in your Slack chat, so you have it there. And I will now see that container, what it's doing, and we'll see that Docker PS, and Docker ps-a. Hey, why did you die? It died. It should not die. I'll demonstrate another example. So this died for some reason. It should not die. So let's go see a different machine. Here is, it should not die. I don't know what happened, but here, different computer. This is live production site. And you have a bunch of containers running right now. And this is the Cloud Genius site. This one, this one, you know this site. And that's the containers are running. I'm going to just reboot the live production site because I can afford to. I should not. In larger sites, you don't do this, but in smaller sites, who cares? I'm going to take that risk and just reboot my production machine. Boom, it goes. And so my site is down right now. Yes, cannot be reached. And so that's good. Now I'm doing nothing else. I'm just waiting for it to come back. And as soon as it comes back, I will log in. Right now it is rebooting. And I'm going to wait for it and connect it, which means my site is back up. And it's a bad gateway because it is still, there it comes. So the site came back. The containers are still running. And the containers run and they survive a reboot because it's a daemon. In this demonstration, it died for some reason. I don't know why, but it did die. I should not have died because I ran it like a daemon. So if you see my history, I said daemon. It should not have died. It did not die. You know why? You know why it died? Because there is no running process. That's why it died. There's nothing to do. There is nothing to do. In fact, let's do it again. I'll explain very clearly now. So I understand what's going on. So if I run this daemon again, you will see that it already is dead. It is dead already here. This one Alpha Charlie Echo is dead already. Here, one Alpha Charlie Echo. It exited because there was nothing to do in the container. You see, our container says, do nothing. So when it has nothing to do, it just goes, bye-bye. See, our container has copy a file. That's it. I mean, there's no action after that. There has to be a running process for it to run. Otherwise, if it has nothing to do, it will exit. That's what happened. That exactly what happened is that there is nothing to do. Whereas in that site here, they have there is work to do. Like for example, run Apache process. So it is running that Apache process in here, and a bunch of other things are running processes inside those containers because they are supposed to be doing something. In our example here, we don't have anything to do. The do part.
Question.
Yes.
On your Docker file, you have the tab to do the copy. Wasn't that actually done in the image building, or is the action being done during the runtime?
It's very hard to really hear you, sir. Can you repeat that and a little bit louder? Your microphone is noisy a little bit. Yes.
I mean the tag, the copy tag, is actually being done during the build time, or is being done on the runtime?
Build time. Build time.
Okay, thank you.
Nothing on runtime.
All right.
So there is no runtime action. The runtime action has to be called out like this. So let's go see a runtime example. I'll go to GitHub and show you there. So a runtime example would be something like, here. Let's go pull this. And this is a private repository, but you will find some runtime example here. Like here is a Docker file, very simple one. And at the line number 30 at the bottom, let me make this bigger so you will get what I'm doing. So here is another example. Now let us go look at this. So you see that line number 21 is a runtime example. That's run, right? You have more lines like 18. You also have 13 and 9. So these are run, these will run at the build time, by the way. There is still not an active running process. So let's go see where that active running process is. Not in this Docker file, but this Docker file does say that use the WordPress image. So begin from line number 2, says use the WordPress image. So maybe let's go look at that image and see what that image has. And so we'll go look at the Docker file corresponding to the original WordPress container. So we can go search for it, say Docker WordPress, and then click, and one more click should take us there to the Docker file here. So in that Docker file, what you're now looking at is a CMD. So I should clarify for precisely answering Dennis's question. A CMD is the runtime run 37. A run command is a build time run. Here, 27, this bunch is a build time operation. This is going to run only once when you're building the image. Line number 37 is a command which will execute when you are running the container. That's a runtime operation, 37. 27 is not. 27 is build time. 37 is runtime. I hope that clarifies. So line number 3, line number 6, line 12, 27, these are build time. 37 is runtime. It is taking the Apache process and running it in foreground. Okay. Cool. So let us.
Hey, Nilesh. So you remember we ran that, well, initially when we were trying Docker, we ran the Tutum WordPress.
Yes. Yes.
So in that one, I ran it as a daemon and I ran the site. So in that case, even if it should survive the reboot of the parent, right?
Yes. Let's go run that exercise. So here, Docker pull Tutum WordPress.
Yeah, it still died. That's what I mean.
Yeah, it's died. So we'll repeat that exercise and understand what's going on. So let's go see Tutum WordPress and understand how to run it. So Tutum WordPress runs like this.
Right.
So let's go see. So it is downloading that, and I will invoke it in my terminal. I'll invoke it like this is a good one. And so it should get invoked as soon as I think you have to put this in form of a Docker Compose. That's what I'm doing, which I don't run daemons like this directly, but I think daemons should survive a reboot. Let's see if daemons survive a reboot without Docker Compose. So Docker Compose is the tool that that I use to construct, and then it survives. I've seen that in real life. However, let's go see if Docker daemon survives a reboot. You have to put this line, restart always. That line is, I think, important. So where is that line in the Docker file? Restart policy, that line. But you use that line, restart always, to restart after reboot. So we have to see Docker command restart always. How do you specify in the command line? Docker restart always. And so that this command will describe that. Restart operation. How do you say restart string? So the default is no for a restart. You can say always. So dash dash restart always, that's the line to add in here. So we have to add dash dash restart always. And then it will survive. And let's go test it. Okay, that's my understanding, but let's validate that. So here, and paste. So it is running a container, which is this container tutum 66.8 brother, that one. And we can verify that Firefox localhost and confirm that it is opening the site, and it is nice. Let us reboot. So we will go click shut down and reboot and wait for it to happen. I think it will survive with the restart always included. That line should save it from it'll restart basically if it kills. Let's go see what actually happens. And then we will change topics. But by the way, while the machine reboots, I would like to ask you this question. How are we doing? I mean, you've seen 8 sessions. Today is the 9th day. How are we doing? That's the real question I have for you. What do you think? What's the answer? How is the program going?
Learned a lot.
Learned a lot. Okay. Anybody else? Silence.
Mute finding challenge. Great. So far, it's a lot of new things, learning and all that. So, it will take some time to sink in, but it's great.
Thank you. So what I will do, I know, I really understand that it is a lot of information, a lot of new ideas, a lot of content, a lot of new ways of doing things. So what I'm proposing to do is to leave access to the content open for you for a longer time than the program. The program will finish in whenever it does, like 2 months. But I understand that it takes a little longer for you to digest, and you may want to revisit the content. And so I will extend the time that you will have access to. And if you want to get more time, I will absolutely. I think programmatically, the machine is set to disable access after 100 days. But don't worry about that. That's what I'm really saying is that, my goal is no test, no measurement, because I think it's futile. My goal is to actually master and practice, not pass an exam or get a grade. And that is stupid. I don't do that. So we don't have that idea. All we focus on is really, really understanding and mastering and putting it to practice. So with that understanding, what I'm saying is, take your time and digest this and put this in practice in real life. And that is what makes me happy. And that's what I'm really asking. Is take this, and I will keep giving you access time, so it will not expire on you. Don't worry about that part.
Okay, thank you.
But please do actual repeat, revise, and really digest the information and come back on chat. And we will talk more, right? Even if the program is over. I don't care. Even if the program is over, even beyond that, you want to talk and you want to do something, you are welcome. You should do that. But that is the goal of the program, is to really make you understand. And that's what I'm trying to do. And I think I want to succeed with your help. So please help me do that.
Sure, thanks.
Yeah, that would be actually really helpful because, sometimes the assignments, even though we try to catch up, we won't be able to catch up with the day-to-day activities that we have.
Yeah, all of you have a full-time job, and I understand that. So
having that extra time to spend more time practicing will actually help.
Yes, it does help. And so that I've seen this, people who really want to study and learn and practice and understand and apply that need more time. And it is these things are complex. They're new to you, right? You don't do this every day. And so that's the challenge, is that you need more time to really, and you have work to do, right? Go to work every single day, like Monday through Friday. And that consumes time, like 40 hours at least, sometimes more.
And also, Nilesh, by the time you're digesting just the term, the terms that we have learned, the next day comes and the new terms are there already.
I know. And I'm going to just start this DevOps thing pretty soon, which is we're going to throw more things at you, and that will almost overwhelm you. And so that is the challenge that I think we have here is technology moves.
But good thing is at the time you're explaining, it's not that it's not being understood at that time. So it's just that it doesn't carry forward, like it's not synced in. So you have to re-practice those.
Yeah,
and so your extension will really help.
Yes. And I think that the digestion of sinking into the head as to how will you apply, I think that needs practice. That needs practice. And I think that practice needs time. And I understand. And I'm going to be available for you. So, the site is going to be available. I will change the layout a little bit. You've probably seen that I'm changing the site a little bit here and there. Like things move along and, things rearrange. Sometimes new things pop up. And I do it all the time because I am creating new things. But you will continue to have access as long as you need it. It's going to die at some time, like 100 days from when you first started. But if that happens to you, just Slack chat with me and tell me that, it died on you. So I'll reactivate, manually go to the back end and activate for you. So it will die again after 100 days, but don't worry about this thing. I'll again activate. If you need more time, I'll add more time. No worries. And no charge. So yeah, it's going to be available for you. Don't worry about this thing. But please practice and please put this to use in real life. That's the only ask I have. Thank you, sir. Okay, let's see what happened to that machine. Is it running?
Yes, it is. I tried.
Okay. Yeah, it seems to run. So it survives a reboot if you have this line. Restart always. And that's the catch. It basically restarts the container. If you don't have that line, it just dies, which is expected. It's a design. That's a design. And so I will, at some point we'll talk more Docker, and then we'll introduce more new concepts such as Docker Compose concept and Docker Swarm concept and a bunch of new concepts. These tools are like 2 months old. Some of them are really literally 1 month old. And so the concepts are fairly new to me as well. So let's see, Docker release 1.12. When was it have the release notes 1.12? When did that happen? So Docker releases for 1.12 happened 1.12.2, no, I want 1.12.1, and there's a 1.12.0. That's when it first came out. So 1.12.0, the previous, yeah, so it's like here. So on July 28th is when this thing came out called Docker Swarm technology. That's the first time it came. And so it is July, and today is what? October. So it's like 3 months. August, September, no, not even 3 months.
Actually, it is 2 months.
2 months, yeah, it's 2 months. This is a fairly new technology. So even I'm new to this, but I'm learning it so that I can use it. And that's what I typically spend most of my time on, is adopting new ideas, new technologies. These are beautiful technologies, no doubt about it. It did not exist 2 months before this new concept. So the documentation is new, things are in flux, and the same applies to this thing called Chef. Same thing, very heavy active community behind it. These people who are developing this application set. It is being used by a bunch of companies, like large companies you can think of and see who are using it, who are the customers. We can view all of these customers that are big name companies in the industry that are using that product set, and you can see more and more. And so in every aspect, you can see all of them. And so here is a large list of companies that are using this particular software called Chef, which, by the way, we are going to use the open source version of this. So it's very, very similar. Actually, it's the same, except there is no support available. So we go to GitHub and use the Chef software from GitHub, as opposed to going to their site. We'll use the open source version, this one. Similarly, we'll also use this open source software called Ansible, which is a company now acquired by Red Hat. And so it also has amazing popularity in terms of its usage and its customers and its community behind it. And lots of people use it worldwide. And this is the company behind it. However, we will use the GitHub version of Ansible, which is this product from this repository, which has, by the way, 19,000 stars and 5,793 forks. And how many people contributing to it? 1,494 people contributing. There are 1,000 issues, 1,090 issues, 428 pull requests, and the code is 20,821 commits. The branch, most recent stable branch, is tagged 212. 212. That's the most recent version. And there are a bunch of branches and all that. So that's a heavy developed product. Tons and tons of people are using, collaborating, creating it. And same with all these open source, really popular products are like that. In your companies, like Boeing, for example, you are actively using Ansible, and I know people that are using it. So you should go and contact them and understand how they are using it. You're also using Chef, I understand, and that makes it interesting. So in our DevOps segment, which is we're going to start today, which is, hey, by the way, a question: when you visit this page, do you see the access to DevOps? You should see that. When you see this section that I just gave you a link on, do you see that you have access to DevOps or just cloud technologies? What do you see? I want to make sure that you have access. Apparently, I don't have access. It doesn't show me. So I'm going to fix my own access. But you should have access already. I forgot to add myself.
Yes, now we see all three courses.
Exactly. You should see, all of you should see the three in this segment. I apparently don't have access for some silly reason. So let me add myself. I have admin access, but not course access. How crazy is that? But that happens when you are playing around with the site a little bit. That's what I was doing. I've been doing with quite some time, and I've actually redesigned the back end completely from a caching perspective. So let's go find Nilesh here, and come on, show up. The search in the admin dashboard is very slow. And this is Nilesh. There are 3 iterations of Nilesh, which is crazy. These are dummy accounts that are used for testing. And I'm just adding myself permissions to it. 1, 2, and 3, and off we go. So we should now see courses showing up right here for myself. By the way, there is a intro to Docker hands-on session I will be doing this Friday. So you are welcome to join. It will be live streaming. You probably have seen it already, but so it will be somewhat boring to you, but that session is there. And so that is intro to Docker, not this, the one after this, or maybe this one. Yeah, the intro to Docker session that you have here is going to be live streamed on Facebook at Friday, 10 o'clock. And so the access to the other 3, all the 3 should show up, like 1, 2, and 3. So here is DevOps section, and that one is the architecture section. They all show up now. Cool. So now you should already have access. So in this segment, we intend to understand what DevOps is, how do we make use of it. There is some conceptual understanding that we need to have in order to really put our thinking around this concept in terms of what it is, how to make use of it, and what exactly it is. By the way, not Chef. DevOps is not a tool. DevOps is not GitHub. DevOps is not a person. It is not a role. So that's what I'm trying to describe to you is people use the word like it's a title. It is not. It is not a tool. It is not a technology. It is a way of collaboration. So what is DevOps? It's a way of collaborating. It's a people thing. It's a more of a human resources thing than a technology thing as such. So what is DevOps? And who coined the word DevOps specifically? So there is this person whose name is Patrick Debois. He coined it, Patrick Debois. And this gentleman, who is an independent IT consultant in Belgium, he first started using the word DevOps, and it is basically a combination word. So if you look at the word itself, it is a combination of development and operations. Combine them together, DevOps. So what is this? What exactly goes under the hood? The meaning of it as described in Wikipedia. So let's go read Wikipedia. What is DevOps? So in DevOps, the description here is like this. DevOps is a clipped compound. Oh, clipped compound is a new word. The definition was, before the people, the collectively accepted word was, it's a portmanteau. The portmanteau actually means a combination word. If you think porter, manteau, that's a portmanteau. It's a combination word. Basically means two things together. Fuses the sound and meaning of its components. That's what portmanteau is. And so this definition earlier used the word portmanteau, but now it uses the word clipped compound, whatever, doesn't matter, same thing. It's a development and operations is a culture. DevOps is a culture. It's a movement or a practice. It is not a tool, it's not a person, not a title, not nothing else, but it's a movement, a practice, a culture, a way of doing things. That's what DevOps essentially is. And so you can see and you can hear these ideas where people are saying, hey, are you a technical person? Are you a test person? Are you a developer? Are you a DevOps? That kind of questions we hear them in big companies like Microsoft, but no, there is no such thing. It's a culture. It's a way of operations, a way of doing things. And so what does it do? It emphasizes collaboration and communication of both software developers and other information technology professionals, while automating the process of software delivery and infrastructure changes. That's the idea. So the goal is to automate the process of software delivery and infrastructure changes. Essentially what we're doing is, we have this dev people and operations people and a bunch of other types of people like test people and QA people and marketing people and sales people and other types of entities, X, Y, Z people. So, there are other roles, other types of people exist. Let's put them all together and make sure that they have a way of collaboration and communication. These two things are critical. And the goal is to deliver software to customers. And also manage change. Change in software, change in infrastructure, change in basically whatever it takes to do this one thing. That's the goal. The one thing is to deliver customers with services, primarily through software. So software as a service is one example. It's a way of collaboration and communication among these people. And while doing that, you are basically managing change in software, managing change in infrastructure as according to Wikipedia. That's what the collectively agreed upon definition is. There is no body that regulates this definition, like the cloud computing definition, as you know, is regulated and controlled by the government. NIST kicks in and then say, here's the definition. And that definition itself is like 6-7 years old. So the definition has, I think, a little bit diluted. We need to revise that definition at some point. But for right now, that is the definition. That's what NIST decides, and that's generally accepted. In concept of DevOps, this is the collectively agreed upon definition, as you see here. If you change anything in this page, people will come and edit collaboratively together, and they will make this different to what collectively is agreed upon. And so that's what you're really looking at, is automating process of software delivery and infrastructure changes. It aims at establishing a culture and environment where building, testing, releasing can happen rapidly and frequently and more reliably. And that's the key concept here, is you want to be able to rapidly and frequently iterate on your software delivery to customers. You want to do this rapidly.
I don't think they've got to the last one yet.
Sorry?
I don't think they've got to the last word yet, reliably.
Yeah, reliably. That's the key. You have to keep doing it. And so make sure that you do it, and you do it in a way that successfully happens. And so I understand, Mark, where you're coming from. I don't want to comment any further on it in the context of your company. But
I'll just say one word, Windows 10.
Oh, man. Don't bring it up, man. Don't bring it up. I feel bad.
It's unfortunate.
I know. I can speak about it on a one-on-one coffee with you, but not right now. Not talking about it.
Right.
No. You're not talking about any one particular product or any one particular company at all. No. Sorry, Mark. In fact, many Boeing employees refrain from talking about Boeing at all, because it's a practice that they don't want to talk about their company, which is a good thing. Don't necessarily do that. And so we have a system of talking about. In fact, funnily, we always refer to these two big companies, the Boeing company and the Microsoft company, as the ABC company and XYZ company. If you have referred to previous recordings, you will have these references that we will, if you watch earlier recordings, we talk about XYZ company a lot without referring their names, because then we generally agree upon that this is what it means, so nobody actually gets the concept. So we will talk about these things occasionally, but not specifically about any particular company or any particular product. Unless there is a objective study that you want to bring up. In that case, yes, we will talk. But I don't want to badmouth any particular product or a company. That's what I'm really trying to accomplish. So we hide it under the guise of some randomized names. Cool. So welcome, Mark. So what I wanted to ask you, Mark, is which I asked other people already. How are we doing? How was the 8 days, and we have 9th day today? How are we doing?
So far, so good. Yep, it's a lot.
It's a lot. Yes.
Yep.
And so I agree. It's a lot. It's a ton. It keeps increasing in its quantum, and new things pop up every single day. And I'm learning these myself as I talk about them. And sometimes you will have that things will change upon us, and that's the key here, is things change. And so you have to manage that change while you build, test, and release software, and rapidly, frequently, and more reliably. Now, this more word is very objective. How much more and how much reliability? Is it 100% reliable? Absolutely not. No, there is no such thing as 100% reliability, because that's how fact of life is. Something will fail at some point in time, no matter what you do. As long as the best scenario is, as long as the customer doesn't see it, you're okay. Generally okay. As long as you hide it from the customer, you can have downtime. As long as the customer is not impacted. Like, I just rebooted the Cloud Genius servers, and you had the site going down, but customers did not complain. At least they did not complain to me, and so I am okay. I took some few seconds of downtime, but I think that's okay. So as long as customers don't complain or don't notice, or even more importantly, are not financially and otherwise impacted by downtime, that I think constitutes a good enough reliability. As long as you don't impact your end user, as long as you don't impact your end customer, you're generally okay do whatever you like inside the company, as long as other people outside that depend on you don't get impacted.
Nilesh, one more thing. This is Mukesh. So I'm coming from a background with the data center, very, very large system on dedicated system and all that because of the custom way of Boeing doing things, right? These things are definitely new to me, and I'm trying to migrate onto this newer stuff. There is another topic that keeps popping up all the time. So just help me understand how that blends into this, about all this big data, Hadoop and all that. How does that blend with all this cloud stuff here?
Yeah, yep.
Because you keep looking into all this newer stuff all the time.
Right. So I think what you're talking about is you just mentioned this idea of big data, right? And with that idea, the idea essentially translates to a key benefit. The benefit here is that you want to make data-driven decisions for yourself, for your business. That's the key goal behind big data. You want to decide not by gut, but based on data. Now, the data is so big that it doesn't even fit on one computer or maybe a bunch of computers. But it is so big that it cannot finish operating on real time, meaning there is more data that comes in every 24 hours, more of it, than what you can process in 24 hours. So if you can process only this much data in 24 hours, there is more data coming at you every 24 hours. And that accumulates over time and it immediately becomes big. So that's the challenge in big data, where you have more data thrown at you than you can manage on one single very large computer. One very large computer, you cannot really fit in and process the data that is needed to be processed every day, 24 hours, but more data will be thrown at you. So it is impossible to, even buy the biggest computer, you still cannot finish processing. It won't even fit on the hard disk. The HDD that you might have is too small. So how do you solve this problem? That's what big data does, attempts to solve in a simple example sense. But ultimately, what they are really trying to accomplish is this. They want to make decisions based on data, not based on gut. It is not gut-driven decisions. No, data-driven decisions. And so to enable this scenario, you need tools, you need capabilities, you need infrastructure, you need specialized software such as Hadoop, for example. And then it comes with its own brethren and its entire ecosystem. And this started in, like, say, 2004 timeframe, and the guys like Pankaj Ghemawat and other guys came out with a white paper on Google way of processing. It's called Elastic Map Reduce, and that original white paper written by Google. This white paper was essentially converted into a product which is done by people from Yahoo, and that product eventually by Doug Cutting led to creation of this open source product called Hadoop, which is basically an implementation of the white paper, the Google white paper. Google never published their entire source code because they still keep it private, but they did a good thing in that this guy Pankaj, what's his name? Pankaj, some Ghemawat from Google. This gentleman published this white paper, and that led to this guy from Yahoo implementing that thing in form of Hadoop as a product. And that is open source. And that product has now been mainstream. Basically, everybody's now incorporating, using it. Microsoft has its own implementation called HD Insights. Cloudera and a bunch of other companies in the industry are basically using this product to create their own MapReduce and HDFS file system based storage solution. So these things for the algorithms to run on multiple collection of computers together needs underlying infrastructure. That's the primary thing. You need infrastructure, you need code to run, you need software like Hadoop, for example. Another software that is very popular these days is called Spark. And it does what Hadoop does, plus a whole lot more. So it is Hadoop plus, a whole lot more things, and very, very fast. So it's very fast in terms of its performance. So that application needs to run somewhere on some infrastructure. Again, it really boils down to infrastructure. Now you can take these things and run it in your data center, or you can take these things and run it in the cloud.
Okay, that's where the blend comes.
Right?
That's what I was saying. So that's where the blend comes. Like you use the cloud infrastructure if you wish.
Yep, you can run it in the data center if you like, run it in the cloud if you like. Wherever you run, you absolutely need infrastructure. You need software, and you need a way to ingest the data, process it, and store it in a place where we can reuse it. So you can basically do analysis on processing that data right here, and based on this analysis that you will conduct, that you will be able to have your business people, and these people are typically not you, typically not people like you and me, but these are the business decision maker, like the CEO of the company, for example, or other people that help the CEO in making that decision, is to whether they move a particular thing from A to B. Any kind of business decision should we take. That decision making from a business perspective needs to happen at a business level. And these guys don't understand data center. They don't understand cloud. They don't need to, because that's not their focus. But the focus that we have is to be able to allow them to have access to all the things that are needed to make sure that they can run their analysis. And then based on that analysis of this gigantic stream of data that keeps popping in from every other place that you can think of, that they can do DDD, data-driven decisions. Because that's what a business needs to do, not gut-driven decisions. This is the gut. But this is data, is what you want to focus on and decide. So to enable that scenario, you need to be able to have a method of managing either your data center itself or move it to the cloud, and then deal with your data and processing and software and the underlying infrastructure and the design. And that's so this model of using big data analytics is like one application, one large application that you can put to use in the cloud. And you can put a variety of applications there. This is just one. So big data and analysis is just one of the applications. It's a very popular one, but then there are several other types of usages that people run into. People actually implement and use on the cloud in the infrastructure, and make use of that for. This goes for business decision making. Other applications will have their own other functions and other roles. And in the third segment that we have in the architecture segment, we'll actually cover a variety of application sets, variety of different applications as to how these applications get deployed on the cloud, and then what's the use case model, we'll do a bunch of case studies in that example. So it is going to be a different experience for you to go through the third segment. So in the first segment, what we did, we have these three. The technology segment, which we covered, like, it's more like a horizontal survey of what is in the industry going on horizontally. In the second segment, we are going to begin deeper, and we'll use Chef, Ansible, and Docker. and go in depth in understanding what these tools are and how they make use of in the context of doing what that definition says. So the definition says, release software rapidly, frequently, and more reliably while collaborating and communicating with team members. That's the goal that we will keep following. And then we'll understand this. This is going to be deeper, by the way. So it is not horizontal, but depth focused. And in the third segment we will have is business focused, which is use cases of how a customer would use a variety of application types. So variety of applications, and how do we apply the concepts we get from here as well as here, and to put that to a usage scenario, and build something of interest to you, depending on how much deep you want to go. Sometimes, some of you in the past have actually built useful products, and you're using it internally for your own use case, and that is welcome, totally welcome. And so you want to identify one particular usage scenario of your own use and build something in the context of what you study here and here. Or alternatively, you can just understand what are the variety of applications that people are using in the industry today. A variety of industries, not just aerospace, not just software development, but a variety of industries, banking, financial services, others. What are they using it for? Movie delivery, Netflix. We have a big case on Netflix itself. How does Netflix take their applications and deliver that end user experience of TV watching, movie watching to the end users? And all of that infrastructure by Netflix is actually sitting on the Amazon cloud, AWS. All of Netflix sits right here, but they are able to run their services without having a data center. There is none. They're purely on this cloud. They don't have a building from a data center perspective, and their entire operations, entire business runs on the Amazon cloud. How are they doing it? What goes in under the hood to build a scenario where a user can just go to Netflix and visit their site, log in, and watch a movie? All of these things, we have a case study that goes in depth in understanding how does this company do it? What does it take to build the entire business that we know as Netflix? And so similar things, we have had a case discussion on the prior time with some Microsoft employees discussing how to deliver the Surface book from all the way from its manufacturing in China to the stores, the Microsoft stores worldwide, wherever they are. And the entire supply chain, how do they manage that using Wipro-based software? So we had a bunch of Wipro guys and some Microsoft guys in the last courses that discussed that study. So that group focused primarily on that. Another group from Boeing had this idea of Boeing's commercial aviation application, in which the idea is to Boeing commercial aviation. The application set is basically the customer is company like Emirates. And Emirates wants to fly a plane from, say, Seattle to Dubai. And as the plane flies, in the middle of the flight, here somewhere, the plane might detect something, going bad. So it might send a signal back to the ground saying, I need a replacement part. And these planes that fly in the air are constantly sending data down. In fact, that's one of the big data projects that Boeing has. They're constantly sending data from the flight as they fly from one place to another, is that I need a particular part replaced. And so don't waste my time on the ground. Make sure that the system, this Boeing commercial aviation application, is able to detect that need for that particular part for that plane that flies tomorrow, it arrives here. So it communicates back with Emirates, tells them to provide this replacement part, and sells that part to them, by the way. And that part becomes available to the plane as it lands at Dubai, and while in that 1 hour or 2 hours of window that they might have on the ground, that they're able to put that replacement right in there so that they minimize the downtime. the more time a plane flies in the air, the better off Emirates is. And the less time on the ground is a good thing for them. And eventually it's a good thing for Boeing. And that's what this entire system is around, is to, they have it, by the way, functional. Boeing has this system functional. So the idea is to be able to proactively detect problems and provide exact just-in-time information for the part to become available at the right location, the right part at the right location at the right time for the right plane at the right gate, and make sure that the replacement finishes in time before the plane flies ahead. The plane might then go from Dubai to, say, Bangalore. And I think, I don't know what it's SBC or what, but some short code for Bangalore. And then that's how it can travel without wasting time on the ground on the airport, Dubai. And that's the value to Emirates that Boeing wants to provide. For Emirates, by the way, is a huge customer. And so is Etihad, and all these airlines that are, are probably the biggest airlines these days are the Arabian Airlines, like Emirates, for example. They have a ton of money, and the gas is free for them, more practically free. And so they're able to compete very effectively against all other airlines because the cost of goods is very low. Gas is free practically, and they provide good service, and they're flying everywhere. So that makes it a really big market for Boeing, especially the Middle Eastern airlines. So that's just one, another case study. So we'll excuse me. So in this segment, we'll go case studies after case studies in understanding and relate back to whatever we discussed in terms of the depth as well as breadth perspective, and apply that to build scenarios of usage that you may want or you may find interesting. That's what you're looking at coming ahead. Now, I must caution that this particular segment that we are going to do, the DevOps segment, is going to be deeper, which means it will be a whole lot nerdy than what we have been before, which means you have to really pay attention and religiously follow along, meaning religiously as in, let me show you what I'm talking about here. So our examples, and in here, we have a ton of activity to be done. Now, this can be done mindlessly. We have a ton of things to do, and you can just copy and paste and mindlessly do these things. But I don't want you to do mindlessly, honestly. If you just follow it along, it will succeed. You will follow through the exercises, and they will all succeed. But that is not my goal. My goal is to make sure that you really attempt to understand what these things are doing, not just blindly take this code segment, copy it, and put it in a notepad and paste it like that. No, that's not what I want you to do. Not at all. Anybody can do that. That's not the goal of the program. The goal is to really understand what is going on under the hood in terms of these things that are happening. That in this example, we are defining something like a role for a node. So I want you to really understand what exactly is going on and how it applies. And more importantly, what does it mean to you when you're doing something very different from what is described here? So in this series that we have tons and tons of material that we will practically not finish in the 8 sessions that we have for DevOps. There is so much content that you cannot finish it practically. It's understood. There are lessons and exercises that are available that you can follow along, and they will work. Because I have been doing this for like a number of times, and I've made sure that these things work. They're written down in a fashion that actually makes sense, and they will work. But getting them to work is just half the story. That's not the goal. The goal is to understand how to use tools like this to make a scenario complete for your customer. To make something of interest to your customer is the primary goal that I would like you to keep in mind. So instead of blindly copying and pasting, like we can actually do practically, shut down your brain, take it from here, go to that virtual machine, and copy and paste. It will work. It will work as long as you're scrupulous in following along. It will work, but that's not the goal of the program. that is not exactly not what we want to do. What we really want to accomplish is something like this. That understand that these tools are essentially for one key thing. And that key thing is actually very well documented in a book. The book is called The Goal. And this is a textbook in MBA programs. At least it was my textbook in University of Michigan. So I think we have a University of Michigan person here. I think he's not here right now. Diego is not there. But University of Michigan has a MBA program in which this Goal book is a textbook. And this Goal book it has nothing to do with technology. No technology here at all in the book. The book is written by this gentleman. His name is, let's go find out his name. So his name is, forget his name. What is DevOps? There should be a lot of references somewhere here. Next unit. Where is the goal? Yeah, the goal is, here is the book summary. So Goldratt, that's his name. The professor who wrote that book is an Israeli professor. His name is Goldratt. Eliyahu Goldratt. Amazon.com, and you should be able to find the Goal book there. So this book should be available. It's a very short read. It is a bestseller. It is available for used for $3. So I would recommend that you buy it. But if you don't want to buy, you can always go to the library and go to this location, which is called KCLS for you. King County Library should have the book. So just go to this location and download the book electronically and read it. It's just a very short book. You can read it like over the weekend. So maybe tomorrow or something, you should find this online and read it. If not, this, by the way, is not a required reading in the program. It is not a required reading because I have a book summary provided to you already, which is right here, chapter and chapter summaries. You can just read that. That's a shortcut. So I'm giving this shortcut to you to understand what goes in the book. So there are like some very short, it's basically one page and 40 chapters, very short summaries are available. And that is what is written down here for you to consume. And now let us briefly talk about that concept that the book describes. So the book defines, by the way, it has nothing to do with technology. It has something to do with manufacturing of some parts. So it's some mechanical operations in some factory somewhere in Middle East. Sorry, not Middle East, but Midwest. So somewhere in Midwest in Michigan area, that's where the book apparently is, in that region. So it's about manufacturing of something. Now, why the heck am I talking about this book? It has nothing to do with technology and something to do with manufacturing. How does it relate to this concept of DevOps? So let me tell you that although this word DevOps is kind of new, relatively, a couple of years old, the concept is not old. The concept is like ancient. The concept actually originates with this person by the name, what's his name, Deming? This guy, who was born in 1900, he and a bunch of other people together created different concepts. And the best implementation of this concept that he created is actually implemented in Toyota company, Toyota Production System. So this TPS that you have, which is known as Toyota Production System, is a system of operations in the Toyota company in which this guy, Taiichi Ono, this gentleman, he basically revised his entire operations of manufacturing Toyota cars in Japan in 1950s to compete with the American car makers like GM, Ford, and Chrysler, and to compete in such a fashion so that the cars that Toyota makes is a lot more reliable, at least in 1950s, a lot more reliable than any other car on the planet. And the reason that they did this is for profitability primarily, in order for them to be able to export cars in the US and continue to provide a long-term value to customers who buy Toyota cars. And these are the original leaders in this concept of implementing the concepts that underlie this discussion we are going to have about DevOps. And so this concept, which is what we studied in our MBA school, which is nothing to do with technology there. It is about automotive manufacturing. And the core concepts here is written down like that. So there's several principles. So he talks about waste. He talks about just in time. He talks about how sales processes and sales process engineering can improve sales and marketing and customer service. He talks about delay, waiting, or time spent in a queue with no value being added. But this is a very common concept that you can take this concept of delay, waiting, or time spent in a line where something is happening, where nothing actually is done valuable. And you work in big companies like I used to, and you do. And you've seen this phenomenon happen in Boeing, in Microsoft, in any large company. You will find this, forget large companies, even smaller companies sometimes run into this problem of delay, waiting for something. You're waiting for something to happen, and that's a waste of time. Another scenario, line number 2, producing more than you need. Meaning you create something that may not be useful for the customer. For example, you might have, I'll talk about my product. My product is this thing called Link. This Link product, these days known as Skype for Business. This used to be my product long ago. And so in competition with this product, there were teams in the same company that created Windows Live Messenger. And there's an application known as conf.exe. If you remember old Windows, there used to be a conferencing application called conf.exe. We used to have the Windows Live Messenger. I said there were 4 or 5 different iterations of the same concept of communicating and collaborating in terms of software like this. And then Microsoft eventually bought the Skype application from outside for a bunch of $1 billion. And that's another one. So we are basically identifying the use of using software for communication and collaboration. But then in the company at that time when I was there, we used to have 5 different iterations, 5 different teams working on the same concept. And I think in some sense that is producing more than what you need. You don't necessarily need Live Messenger and Windows Messenger and what, Net Meeting. There used to be a Net Meeting thing. Yeah, I remember that. That's another thing. So Net Meeting was another product. It looks like this. And so that product was the conf.exe that I was talking about before. So a ton of different products, they all functionally do the same, conceptually the same concept. And I think that was a scenario where you're producing more than what is needed. The customers are not using these so many different things, but you're still producing them. Another idea, which is over-processing or undertaking non-value added activity. And this is a classic disease. I think it's a disease of big companies where they're doing something for the sake of doing because they want to look good. Individuals do that all the time. They want to look good. They want to make sure that they are perceived better. And so they process unnecessary things, which is of no consequence to the end customer. And that is something that we need to really worry about and think. Transportation. You take one item from here to there for no other reason other than it is needed. In that case, it is okay. But if it is unneeded transportation, you're just shuffling items from here to there, like people shuffle from buildings to buildings occasionally all the time in big companies. Wink, wink to Mark Myers. That's unnecessary sometimes. Sometimes it is useful, sometimes it is practical, but sometimes transportation of people, machinery, equipment, plant, software is unnecessary. So you have to identify what is unnecessary. There's another one, fifth, unnecessary movement and motion. We don't need those things sometimes. When you're dealing with physical stuff, physical goods and materials, there is inventory. This inventory that piles up. You don't necessarily need to build up inventory in large stacks and large warehouses of things that you may or may not sell. And then the seventh one, reduction of defects. This translates to bugs in software. So you have a defect in a car, a defect in a machine, a defect in a software is known as bug. And so you have your bug database growing. That's a problem. Because eventually, as soon as you bring the bug count down to a good, decent, manageable number, you cannot really sell the product. And you want to really sell the product because that's where you make money. There is no other way. There is no other way. And so these are the concepts that I think really, these are not new concepts. The concepts are in there, documented in many books. The concept of just-in-time, the concept of lean manufacturing, all these things existed years and years ago. And these things are not new. The application of these concepts created by people like this guy or this guy are essentially distilled in form of this concept that we are now these days talk about, DevOps, and these concepts are now applied in the context of software development and delivery. This development and delivery typically happens over the internet. So via the cloud primarily. That's the dominant model of delivery, that you create some software and you primarily deliver it via the cloud to your customer. And that's the ultimate end result we want to be able to accomplish. And we want to apply the learnings, the technologies, the concepts, the principles that other industries have adopted already, like the example of manufacturing I gave you from Toyota Production System, and take that concept as it applies to software development, as it applies to delivering our software as a service to our customers using the cloud. In that context, whatever makes sense, people have collectively applied that knowledge and they call it DevOps, practically. There are some things around it to make things smoother. There are adaptations around it to make it apply to development of software. And by the way, the goal book, as I said, has nothing to do with technology, but about manufacturing. So it gives you a perspective on what really the book is trying to accomplish in terms of these principles that I just described here that Tai Chi writes about. I mean, this guy has thought through these things and has applied it in this production system called the Toyota Production System, which is this one. And you should read these links. I'm going to just paste these links for you in Slack chat. They are probably there on the site already, but I'm just dragging them for you to read. And you should review that quickly on that page. So with that discussed briefly, I will now talk about and ask you this question about the goal itself, and not in the context of the book, but generally speaking, what is the goal of business? If you have a business, what is the goal?
Make money.
Yes, that's the goal. That's clearly understood. Nothing wrong with it. Right? Now let me ask you another question. The question is like this. If I go to Las Vegas and I find a beautiful machine there, and in that machine I will put some money, and this is the only machine that I play there, by the way. I go to Las Vegas, this is the only machine I play. I put in $1 and I get 4 quarters back every single time, repeatedly, absolutely without fail. I put in $1, chunk, 4 quarters come back. I win every single time. I mean, this is the best machine you can play in Las Vegas. Do you know what that machine is? Anybody?
Maybe change machine.
Yes, yes. The best machine is the change machine, because every other machine in Las Vegas is a loss-making machine. This is the most profitable machine, the best machine in Las Vegas. Now, in here, am I making money?
Nope.
No, I'm not.
But you're not losing.
Yeah, I'm not losing, but I'm not making money. The goal is to not just generate money, but actually make money. This make concept is very simple. It is the return on investment. It is the money that I get minus the money that I put, divided by the money that I put, multiply by 100 is the percent rate of return on investment. So this get has to be more than I put, and then I make more. Otherwise, I lose. That's the benefit. You want to make this return on investment a decent return. If this is not decent return, I'm not interested. This has to be decent. Otherwise, I don't want to make that game. I don't want to play that business. Don't want to play that game at all, because it has to be interesting. It has to be decent. It has to be more than some non-zero number. Otherwise, I'll do nothing and I'll just sit on my money, and that's good, because at least I'm not losing. But I need to make better than non-zero, better than decent interest or return. Otherwise, I'll just invest the money in the bank and I'll probably get 2% on a CD deposit, maybe something like 1% at least. So some CDs give you that rate of interest. So that I'll make $101, 101. If I put $100 today, I'll get $1 at the end of the year by putting it in a CD. That's a better return. Now that's too small, too little return. It is decent, but it is not interesting. So I want to make a decent return on investment. That's the goal of the business, in terms of not just make money, but make a decent return on investment. So decent ROI, and keep my cash flow positive. And keep my inventories down. Inventory is anything that I store in the office, in the store, in the warehouse. So I want to keep them really, really down. Ideally, I will make, anytime a customer wants something from me, I'll make it on the spot and give it to them. Don't keep it, don't store it, don't need to have a warehouse, because I think that's a cost that I want to avoid. So these are the goals in business primarily. You want to make a decent return on investment, keep your cash flow positive, keep your inventories down, and add other things like we described here in the definition of DevOps, which is you are in the business of delivering software, so you want to keep doing those things rapidly, frequently, and reliably. You want to build and deliver software. So inventory is probably not a scenario in case of software, because there is nothing to store. You can always make a copy and send, or maybe provide an endpoint where people can consume the services online. So this doesn't apply in the context of a software business too much. So I'll cut that. But I do want to keep in track that I do want to keep delivering software to my customers over the internet via some endpoint, so that the customers can consume those services. And
maybe it's keep labor costs low, in the software development world. Yeah.
Yes, indeed. So that we'll get to that. I'm just coming to that point. So the idea here is software, and you want to keep delivering services, is to think, like, do this reliably and rapidly at a low cost. So that's the kind of sort of like a very short summary of the goal book, if you will. So you should read that book, at least if not the book, read the summary that I have on the website. By the way, all of you should have access to those things here already. So if you don't, please tell me, I will fix it. But I think you should have access to this thing called my courses, in which you should see the 3 courses showing up now, all the 3, which is the architecture one, the DevOps one, as well as the technologies one.
Yeah, mine's showing.
Good. So yeah, I wanted to make sure that. So with that discussed, I would like to talk about another book. And that book is called Co-opetition. And this book is a famous book by Adam Brandenburger and Barry Nailbuff. This book I purchased in 2001. And you should buy this book for 1 cent from here. Totally buy that. It's a very good book. It's not too big, not too fat. And again, this has nothing to do with technology. It's a business book. But you should read that, because it makes total sense in the context of understanding bigger picture. It's a 1 cent plus shipping. So it's totally makes sense to buying it. And so buy it. Don't even worry about waiting for the library. It's a good book. I have it somewhere in my home, but the point is that this book talks about certain things that you are probably intuitively very aware of. That happens all the time, and many of you already deal with this on a day-to-day basis. The book is from, I'll just paste a link for you so you have it. Link in the Slack chat, and now this. So the book is about another combination word like dev and ops together, like cooperation and competition. So you combine these two to make the word co-opetition. That's a made-up word, just like DevOps is made-up word, but it's okay. That's how words are made up. So the co-opetition book is a strategy book. It describes a framework of thinking when you are dealing with anything to do with business in general. And that is what I want to now discuss a little bit. So let us see. In here, I'm going to draw a little picture. So here is you, or rather I should say your company. And here are your suppliers. And here are your customers. And here on the side are your competition. And on this side are your friends. Let's call them cooperators. Or even better, there's another word that I would like to use, and that word is complementors, not complementors. So this word is not I, no, E. That's the word. So the word means that you are helping something happen. That's the framework that I would like to use. So not this compliment I word means, hey, you look good. That's not the word I'm talking about. I'm talking about this word, E, here. So that's the framework of discussion I would like to have. And with these elements around the central company, I have competition to worry about. I have my complementors that help me. I have my customers to really, really worry about, and then suppliers to deal with. That's how I think about a structure when I'm running a company. Here. Now let us take an example. I am the
Hey,
company.
Nilesh, can we have 5-minute bio break?
Oh, yes. Oh, sorry, I forgot. Thank you. We can do that right now. Yeah. So let's take a break. Right now is 10:05. We'll resume at 10:10. Break. Thank you. Yeah, I just keep talking. I am hard to shut up. But thank you. Yeah. Let me grab a cup of water. I'll be back. Are we back, guys? I guess. Let's see.
Yeah.
Yep. Mukesh is back.
Yep.
Okay, sir. Let's proceed. Let's proceed. So I think we will, sprinkle the discussion of strategy as we go along occasionally as we need to. But in this frame that we are talking about, I would like to discuss a couple of things. Those things are essentially take an example of something that you will find and relate to very easily in the context of what you have in the companies that you work for. It is something that I want to discuss briefly. So what I'm doing is applying it to say begin with the company that I would like to talk about first is say Boeing, for example. So Boeing company, who's the competition? Airbus.
Yeah.
Yeah. Who's the customer? An example, Emirates Airlines. And who's the supplier? Honeywell or GE, Pratt and Whitney, or Rolls-Royce. Those people provide and components that build the plane. And so that's the customer example. And here is a competition example. Where are Boeing employees? Where do they fit? Are they fitting as a customer? Are they fitting as a competition? Or are they fitting in as complementors? So I think that's a somewhat little bit involved to answer that question right away. Where does a Boeing employee fit in the game? Is it here, or is it here, or is it where? Where does Boeing employee belong in this picture? And that to answer that question, I would like to describe a distinctly different example. The example I would like to talk about is, first of all, explain the word complementors very clearly. A complementor is somebody, the mere presence of that thing, of this, makes my product sweeter. Or rather, I should say better, or interesting, more interesting to the customer. So whatever, just by the fact that they are there, the presence of these guys makes my product more interesting to the customer. So if I am, say, making tea, then the presence of sugar makes my tea interesting to the customer because the sugar makes it sweet. That's the classic definition of complementor. Tea and sugar are complementing each other. And so is coffee and sugar. Coffee and sugar, they go together, makes it better for the customer. Just by the fact that I have coffee doesn't make it interesting, but the moment that I add sugar to it, it suddenly becomes interesting to the customer. On the contrary, tea and coffee are competitors in some sense. They substitute each other. This and this. If you just had a cup of coffee, you probably don't want to drink tea right away. That's the scenario. These are competing in some sense. tea and coffee. So I would rather be in a business of selling sugar, because to me, sugar is the platform in which I can add tea and give it to the customer, and the customer is happy. Similarly, I can also add coffee as a complementer, and the customer is still happy. And these guys, to me, coffee companies and tea companies, they are my complementors. That include tea, that include coffee companies, things like that. So that's the distinctly different meaning of the word complementor. They, by themselves, are competitors to each other. But to me, I'm the sugar manufacturer. These two guys are complementing me. So with that definition, clearly understood, in this example, where does Boeing employee fit? Here or here? Because they're definitely not here. And definitely they don't buy airplanes from Boeing, so they're not there. They're somewhere either here or here. Where do they belong?
I'm guessing both.
I will say supplier, because you're
I'm just involved. That's good.
Yeah, I'll say supplier because you're basically selling your time and you're getting paid.
The reason I said both because of the service, because the customer feels better only if you have the service attached to that.
Yes, I agree. But then that service is coming to the customer from here. It's not a separate entity. Boeing provides them service, not this employee. Employee gives time to Boeing and they get paid for it. So that's my placement of an employee will go in the supplier, because to me, employee actually is selling the time to the company. The company in turn is providing services to the customer. And of course, these employees will act on behalf of the company, but effectively this company gives service, not you directly. That's the difference that I would like to call out. Yeah. So that's where I will place employers. But then the question remains, who are these guys? And why? So let's say, this instead of Emirates Airlines, let us put somebody else here, like Delta Airlines, for example. So Delta Airlines is the customer. And now you know who the suppliers are, and you know who you are as an employee and all that. But who are these guys? So imagine something here. The moment you place them in this location, that Delta Airlines suddenly feels that they can buy the plane now. This plane that you want to sell to Delta. Delta suddenly feels, yeah, I can buy the plane. Let me buy a couple of them, maybe 3 of them. What is that thing that exists here that makes it interesting to Delta? That they will otherwise not buy the plane, but just the fact that this exists.
Is it financing?
Huh?
Finance?
Yes, exactly. These are financing corporations that makes it possible for companies like Delta to actually afford to buy the plane. That's right. That's exactly right. And so those companies, like financial companies that assist airlines in buying a plane, because Emirates, I just removed that example because they don't need financing. They have so much cash, they can buy 100 planes in a day. I'm just joking. But that's why I removed the Emirates example, because they have so much cash, they don't worry about financing, but Delta does. Delta will love the fact that they can finance the plane and they can buy these planes because these banking institutions like GE Capital, for example, banking and financing institution GE Capital, the fact that they will give a loan to Delta makes it possible for them to buy this thing.
Exim is the biggest for the airplanes.
I see. So yeah, so that's what. So Exim, GE Capital, those guys, financing. So that's the picture. That this is how a frame that I would like you to have in terms of thinking through anything in general in life. It applies to, I'll take one more example before I switch, and we'll come back to this discussion at some point later. So another discussion, which is focused on the word cooperation now, is this idea of that I am making, in the context of Microsoft, I make the Windows OS. So just the Windows part of the old Windows part of Microsoft. Excuse me. So in this example, we have Windows as the product, and this is just the Windows division, old-time Windows division of Microsoft. And here, who's the supplier? The dominant supplier to this entity are employees. They provide their time, their knowledge, their effort, their everything else that they can to make this software work the way it should work. And these employees are the primary suppliers because there is nothing else in the product. It's just ideas implemented. It's software. The competition is Android, Mac OS, iOS, and a bunch of other Linux OSs. That Android is basically Linux. And so that's the competition. Customer is you, me. We buy that product. Who are these people?
Like ISVs?
Yes, like Adobe, or generally called ISVs, independent software vendors. For example, Adobe and Dell, OEMs, HP, Lenovo. These guys will make the hardware that makes the product work. This is like tea and sugar. The fact that you have Windows doesn't make it interesting to the customer unless you have a physical machine to run Windows on, and that is the hardware. There are a couple of other things that go along inside. So if you now think about these guys, Dell and HP and Lenovo, these guys are, I'm putting them all together in the complementor section. However, if you look at this picture from their perspective, you have Dell and HP and Lenovo. These guys are essentially competing with each other because they are all selling their hardware to you and me. And so we are buying, we have a choice to buy from any of these places. And I'm talking old Microsoft, not the new Microsoft. So they have the choice, they can buy it from any place. Now, you would assume that these companies are practically competitors. They compete all the time, almost all the time, except in some cases, you will see, and you probably know this firsthand, that these companies suddenly behave like best of friends and operate like collaborators. And you have seen that all the time at Microsoft. These companies suddenly come together and become best of friends and collaborate among themselves very nicely. I thought they were competitors, but no, magically on one fine day, they will all start collaborating. And you have seen this. Now, why does that happen? That's the question. You've seen this happening. You will have meetings where Microsoft employees will sit on one end of the table, and you have Dell, HP, IBM, and all of these guys together, Lenovo, other companies, they will all band together like best of buddies, BFF, if you will, and they will fight with Microsoft. Why does that happen? Do you know why?
Advance their common goal.
That's right. Exactly. They have a common goal to have Microsoft reduce the price of Windows license. Whatever that $12 price is, Windows license, bring it down. That's one goal. And it is in common shared interest of these guys to become best of buddies. And they suddenly change their role from competitors to cooperators. And that's the essence of the book that I was talking about. Cooperation. It is not cooperation all the time, not competition all the time, but cooperation and competition together at the same time. That's what's going on right here. It's their interest. And the same thing you will see if you go to the Intel company. These guys will fight just like that with Intel. They'll all collaborate, band together like BFFs, and go fight with Intel because they want to reduce the price of the cost of the CPU. And they will suddenly become chummies, best of friends, and fight with Intel, negotiate hard collectively. And that's a strategy that they are playing because it is in their interest to actually negotiate hard together with Intel and Microsoft, but compete when it comes to the customer. And that changing game, that you change your role, you change your day-to-day behavior, suddenly, magically, depending on the context you're talking to. You're talking to Intel and Microsoft, you're friends. You're talking to a customer, you're competitors, you fight. That's the game. And it is actually a very nice concept to understand this as to why these things happen. Because once you do, you will really have a good idea about another concept, which is an economics concept, by the way. Economics concept. The concept is known as game theory. And there is a book on this, very good book, but it's a very boring book, I should caution. Game Business is Play. It's a fat book, really big book. It's actually a good book, but it is a tough read. That's how I would say. This book, you can buy it on Amazon. It's by Pankaj Gemawat. It's a heavy book. I mean, heavy as in not only physically heavy, but it's very heavy read. And so that's the problem with that book. It's, by the way, a very good book. Let's go search for it on Amazon. You should find a link on Amazon. And there it is. So this book is hardcover, 1 cent. You should buy that. 1 cent book available, Pankaj Gemawat. And the book is right there. Now this is a lot more theory and concepts and case studies and models and some economics. So you may not want all that. Unless you want it, you should go get it. But the other book I'm talking about is a lot more conceptual, which is the cooperation book, which is actually a very light reading with interesting way of describing examples without going to the theoretical aspect of game theory, which is actually a good topic in itself. And this leads to strategy of how you behave, how you perform, how you interact with other businesses, and how you run your business. It's all about how people play games. I mean, economic games I'm talking about. So the idea here is not games and sports games, but business games that businesses play in a variety of cases. So you should see that the reviews are good, but it is a difficult read. I must it's not user friendly. It says that right there. It's a writing in an intuitive and straightforward way is not one of Mr. Ghemawat's talents, at least not judging from his book. But he writes very nicely in a sense that it is actually a systematic way of writing game theory. But some people don't like that concept, so just be aware. And with that, I'll leave you for your interest to explore further if you are interested. I think it's a fascinating topic, but not for this course, not for this DevOps course. So we'll switch to a different topic now, which is in the process of delivering a piece of service to our customer. So we always keep talking about the customer in mind, and in our side, in our company, we will have a variety of roles that people will play. We have, developers, operations, QA, test, X, Y, Z, whatever roles we have. These are roles in the company, and we'll keep them all in the company. And our focus is to make sure that we provide these guys with value in form of a service that we deliver on the internet via some cloud, some service, some software as a service. That's what we want to deliver to them. That's what most companies are doing, by the way, these days. Most technology companies providing some services, some value to the customers, and they do that because they want to get paid. And so you get paid only if you provide value. If you do not provide value enough and you take money, that is called theft. When you don't give value, say only $2 and get $3 in payment, that's theft. And that's not technically theft, but in long term, it doesn't really work out. Technically, it is not theft, but it is maybe cheating. I don't know what the word is, but practically what I'm saying is that if you give value, you better give more value than you get paid for. So whatever value you provide should be more than what you get paid for. And then you can keep doing these things over and over and over again on a sustained basis, at the same time keeping your competition out of the game. Keeping the competition out. That's what you really want to accomplish, is you want to provide service of value to the customer and keep doing it repeatedly over and over and over, reliably, consistently, and then get paid repeatedly, reliably, consistently. So all these things apply because if you really want to make money, the goal of the business is to make return on investment. So you want to keep providing value consistently. Now, value doesn't mean whatever you think you want to give, but the definition of value is whatever the customer wants. So you are basically letting the customer decide what they get. They decide what they get, not you. You may think that X and Y and Z are good things that the customer may want, but customer will say, I want A and B and X. So you better give them X, but don't work on these things. Delete that product, delete that feature, cut it. Don't work on it. Instead, have people work on A and B and give it to them. Don't waste time and effort on Y and Z because the customer doesn't want it. Don't give it to them. There is no need for it. There is no value. No value in Y and Z. No value. So don't waste time. Cut. Now, how do you accomplish these things? You want to do these scenarios where you are delivering value to the customer, and you want to keep doing that repeatedly over and over and over again. And then, inside your team, in your team, in your company, you have these various roles that people play, and you have, the X role, the Y role, Z role, dev role, ops role, God knows what role, IT role, service role, support role, marketing role, these roles. And the challenge is to be able to have everybody synchronously deliver whatever the customer wants, A, B, and X. That's what they want. So you better give them those things, while at the same time, keep iterating on, say, tomorrow the customer says, give me E. And so you want to make sure that you are able to give them, and work your team, have your team develop the E feature set and deliver that to the customer. And you can accomplish these things provided you have a systematic method of operations in aspect of not just writing the code, not just testing it, or not just servicing it, but entire end-to-end operations in terms of whatever you are delivering to the customer. So delivery has to be automated. This automated method is possible only if you are able to accomplish certain key characteristics, such as collaboration, communication, and automation. These things should be done almost, intuitively across the board. Every team member needs to follow along. And that is a very hard problem. Hard, tough. It's a people problem. We are human beings, and we cannot follow rules. Cannot, humanly impossible to follow a rule repeatedly over and over and over and over for hundreds of times. I've seen people in Michigan. I visited factory in Ford Motor Company. I met a person there. His job was to tighten the left front wing nut on the assembly line. That's what he did for last 20 years. I mean, it's a nut job, literally speaking. And that's what he's been doing. That gentleman is doing this manually, by hand. He knows a great level of detail around how much pressure, how much tension, how much torque you apply, and all that good stuff. But that is the only thing he has been doing for the last 20 years, or maybe more. But these days it has been removed. They have been laid off and automated away. But that is a people problem. Is that you don't want people to behave like machines, because people have this thing called brain, which is very fertile, and you don't want them to be used like a machine. We typically do not have brains. Machines don't have brains. They are basically a thing that will automate for you. So you want to have something that is repeatable. You rather give that work to a machine, not to a person. And this is sometimes very hard for people to understand, at least managers to understand, that it's a people problem, that you cannot give a person this kind of a job, tighten the wing nut, the left front wing nut on these cars that come out of the assembly line for last 20 years. And I've seen this in 1999. That's when I saw it firsthand, when I met this gentleman. I forget his name, but I remember meeting him, and he was doing it. And he, at those days, said, 20 years, I've been doing this for the last 20 years, the one job. Poor man, nut job, but that is something you want to avoid. You want to really avoid that problem of repetitive work, assigning that to people. And so there used to be a professor that unfortunately doesn't live anymore, but he used to be at Michigan. And our friend will probably remember, I think you're too young for it. We have Diego here. Diego might remember but maybe not. And so he went to the same school, by the way, the University of Michigan School at Ann Arbor. So that's how he might know, or maybe have heard of him, but he's too young for him to remember that professor, or maybe I don't know when you graduated, so I don't know how young you are. But the bottom line is that professor said one thing, which I still remember, and he's a Nobel laureate, so it's important to remember that also. He said that routinize the repeatable. So very simple line, routinize the repeatable. That's it. Whatever you can do by hand, do it once, do it twice. Third time, you don't do it by hand again. You routinize it. This routinize means automate. Automate whatever you did by hand once, twice, and that's it. You have to have a method by that time that you will not touch it by hand again, because you're repeating that same thing over and over. And as you know already, we are people, we are not machines. So we need to operate like people, not operate like machines. So don't do boring, repetitive work. Don't let people do that work, because they're not machines, they're not zombies, they're humans. So don't let people do repetitive work. That's a waste of human capital, literally a waste. And unfortunately, many companies, and big companies and small, don't understand this, and they give repetitive work to people for a variety of reasons. And that's just bad. It's probably economically viable in India because people are cheap, very affordable. But in this country, it is not. I've seen it, and I am from India. I've seen this, that you can actually give routine, repeatable jobs to people that will take that job and do it for you gladly because they are economically poor. In fact, there is a cloud service for that. The cloud service that I'm going to talk is actually from Amazon. And this thing is called Amazon. Mechanical Turk. If you have heard of this thing, please tell me, but this is a service from Amazon. And it is, unfortunately, what I just described is to, you can read this. It's very simple. Have you seen this service, by the way? Heard of this before? Anybody?
No.
Okay. So this is a, sorry?
You just use the human to do the tedious.
I did not hear. No, speak louder, please.
Is that using the human being to do the routine work?
Yeah, exactly. And so that's exactly, unfortunately, true. And so this is a service from Amazon. It is labeled as artificial intelligence. What does that mean? At the very top here, artificial intelligence. It means human intelligence. It means there are people doing grunt work repeatedly. I mean, just unfortunate state of affairs. But this is a fact of life. Just understand that poor people in poor countries are doing grunt work for people who can afford to buy those services. So there is no cloud on the backside here. It's a service from Amazon, and they are making money apparently on this service and exploiting. Everybody seems to be exploiting those poor people that are doing grunt work. And let us do some examples.
No, I think that's the wrong way to express it. I think that, in the eye of executives, they actually contribute to their well-being of other countries.
Speak louder a little bit, please. I cannot hear your microphone.
No, what I think is, in the eyes of executives, they just try to, distribute wealth to other countries that needs it.
Mm-hmm. Yes. In effect, if you think about it, what is going on the two parts here? Make money by working on hits. And the other one, the orange colored, get results from Mechanical Turk workers. So left and right, two parts here. Make money is one part, get results is another. So the get result part is basically for people in, say, this country, for example. when you have money and you want to get some results done, you assign a human intelligence task, HIT, HIT. So you basically define a very repeatable task and you put that in the site. And then it's a marketplace. So people in India, for example, will go look at these human intelligence tasks. They are repeatable. And then they will take those tasks and perform those tasks repeatedly over and over and over again. And for every task, they'll get paid a very tiny little amount. And they keep doing it and they get paid. And that's the model of business here. Now, if you look at some hits, for example, as a person who may be looking for a job or looking for a human intelligence task to work on to get paid, you can make money, apparently, not too much, but a little bit. So let's find some hits. So I'm going to find hits. And here I'm looking at some example here. So their example is type the text from the image carefully. Productivity and bonuses guaranteed. Requester is copy text incorporated. The allotted time is 10 minutes. And reward is 1 cent. So if you want to work on this hit, basically they will give you a image and you have to look at it from your eyes and type it out. That's pretty much the task is. And you can use this. The reason they use this particular example is that their OCR is not working. So they need human beings who can do the job. And so this is an example of OCR, Copy Text is the company that is making, yeah, there we go. So there are Reddit discussions, is Copy Text underpaying you and all that. So you can read more about these things, but the bottom line is this service is being used by companies to get things done at a very, very cheap, affordable rate by using people as artificial intelligence, meaning human intelligence. And it is called Mechanical Turk. Turk, by the way, is apparently a bad name to some people in some countries. It's not supposed to be a good name, I think, in Netherlands. It's not supposed to be a nice name to call somebody a Turk for some reason. I don't understand this, but whatever this is, that's the product, the service available that is there. So you can see more examples in there. For another one would be input specified values displayed in the image. So you can basically do that job and get paid 0 cents. Why would anybody do that job? But apparently there is a reward called 0 cents. And you have to do that in 20 minutes and still get not paid. What's the point of the job? I don't know. So here, internal workers has been granted. You will be presented with an image of a gym cardio workout console. Your task is to identify and input the duration, distance, and calorie values. And the reward we will pay you is $0. That is very strange. Why would anybody do that? But apparently there is. So the concept essentially boils down to is you want to not do what they're doing, like that Mechanical Turk. You don't want to do that in your company, but instead you want to routinize the repeatable, automate the thing, which means you want to design your service endpoints, your cloud services, in a completely automated fashion to the extent you can. Now you remember the last time we ran this exercise, use this tool called Terraform. And we created 3 machines out there in some cloud, DigitalOcean cloud. And then we configured these things, all of that without going to that website. We did not actually click anything on the website. We used this tool to orchestrate whatever we wanted in form of creating a platform as a service and all that good stuff. The steps that we used Terraform for was to configure our instances, our cloud machines, our droplets in a way that will help us deploy our application. In our case, the application was the service known as Days Platform as a Service. This PaaS that we deployed itself is an application that we deployed on these boxes, 1, 2, 3 together. And the concept that we are describing in this context essentially is that you define your infrastructure as code. Whatever your infrastructure is, you defined it in form of some code that was written down and used by Terraform. So that the folder that we had called Days folder, and then there was this other underlying folders in the source code. There was some code that we used through this tool, and then we defined our infrastructure through code. So if you want to change something in our infrastructure, we don't want to go and muck around with that website directly, but instead we'll come back here in our source code and make changes here and run Terraform again. When you Terraform apply, it will take these changes and apply to your cloud. So your infrastructure updates as your code updates. That's the core idea. So core idea essentially is you put your design or your specification for what you want in form of code in a Git repository, and then somehow manage to run this on some cloud. When you are designing your application, you're designing your infrastructure, you're writing that description, your design infrastructure. Let's erase that. Yeah, you're designing your infrastructure in form of some kind of code that you write and that you put in your repository. You are not going to the cloud directly and mucking around with the design manually. You're not doing this manually at all. Instead, you want to make a change somewhere here in your infrastructure, you go back to your design, change the design, and then apply it. It will apply to your cloud and it will change the infrastructure. That means tomorrow, if I want, say today I have these 3 machines running, 1, 2, 3, and they are configured in a very specific fashion to have something done so that my applications will work correctly. So that is the current design. Now tomorrow my need changes and I would like to have them laid out differently. So I can always go back to my code, change it here. And a simple change can be, a very simple change can be, maybe change this reference from black color to blue color. That's it. The only tiny change I just did. I need to make that change right here in our code. And I just did that change. And so this is the code that I will have. This code is basically a reflection of my infrastructure. This is not the application code, but the infrastructure code. So in effect, if you want to accomplish that by mechanical operations, you will have to get a machine somewhere out there and then manually go SSH connection and modify this particular attribute, convert that black color into blue color, and then you're done. But then the moment you go SSH into the box, you are creating what is known as entropy. Entropy is something, in simple English, this is known as disorder. A disorder, basically, you did something to that machine by hand. You touched it. You touched your dirty hands you basically made that machine dirty. So you don't want to touch those machines, because the moment you touch them, they become dirty. They become dirty not because you are dirty or your hands are dirty or your commands are dirty, but the fact that your team members have no idea what you did makes it dirty. So you and your team, you are mucking around with this machine by SSHing into it, a direct connection, and making some changes here. That's great. You did that, and nice job. And no, you are not dirty. But your team might think that something went wrong because they are not informed. They have no idea what you did because you did not document it. And the code that you have that reflects the infrastructure that you are managing is still the old code because you did not change the code. So the team entirely, except you, everybody else thinks it is still the old way. But you mucked around. You're mucking here. You're modifying something by creating something which is different from the actual design, which is written down in form of a piece of code that you want to apply. And so you took the shortcut and you went around the backdoor, SSH, modification, and that the team is not aware of this modification. The code that you have, the design you have is still the old one. And everybody else is surprised. Why does that thing not behave the way it should? Because the design did not change. You, on the other hand, decided to go muck with it. And you may have a good reason for doing that, nothing wrong with that idea, but the fact that you did it without changing the repository, the central, collectively agreed upon way of doing things in the team. You did something offhand. You just went on your own and did something different without actually formally incorporating that change in your design, and you just applied it. If you wanted to make a change, you should not have gone here directly, but instead go to your team and say, you know what, I want to make a change. Here is a pull request. Take my pull request, please. And in Git repository, you can send a pull request to the team. The team will review, and if everybody agrees, they will incorporate the change into the design. And your Git repo becomes the new change repo. The old one goes away. Then you can just apply. And then your design changes succeed, but no entropy, no disorder. You still are clean and no mucking around with SSH directly.
Well behaved.
Yep, that's the idea. That's the good idea. Just behave properly in the team. It's a large team. It's a large company. And you don't want to be touching machines directly, because the moment you touch it, even though you may be all clean and nice and had a shower and everything, but who cares? It's not about shower or being dirty, but the fact that you're touching something without your team members' awareness and agreed upon approval, it's a bad thing, because you're effectively destroying collective agreement that you have with the team, and that you need to send a pull request. You should test it locally on your machine, a separate cloud or some other cloud, test it in a private area, and then send a nice, decent pull request. Hey, here is my change. Please accept this pull request. The team members will get together and say, you have a very good idea, sir. Let me take your change. And they will incorporate that change into the team, and you have a new fancy design. Beautiful, let's apply it. Bingo. You get the new value to the customer, and that is awesome. That's the core idea. Now, this concept is what we are really referring to as the idea of infrastructure as code. And we will begin using this tool the next time, which is the chef tool, which is one of the ways you can deal with. There are many, many tools available, but we are not focused on the tools per se, but on the concepts. But yes, to run examples that we have in mind, we will use some kind of a framework to apply these things like Terraform or Chef or Ansible or Git or Git is always there, or Docker or any of those frameworks that are out there are immensely popular. By the way, Microsoft also has one. It is known as, what is it called? It's a beautifully named thing, by the way, but it's the name itself is beautiful. It actually communicates the clear idea, but let's read it. You will understand what I'm talking about. So desired state configuration is the product that Microsoft has. It is called, just because it is Microsoft, it has to have a long name. It is not, cannot be a short name. So it is Windows PowerShell desired state configuration. That's the full name. And I think I just like to call it DSC. That's the short name I prefer to call. And the idea here is desired state configuration, which is very, very similar to the tools that we are talking about here, which is, where is that? Programmable infrastructure. So here I will have references to all the variety of tools like Chef, Puppet, Ansible, Salt, CF Engine, and Microsoft PowerShell desired state configuration management, Babushka, and a bunch more like these. So there are a bunch of tools. You know, there is a huge collection of tools you can see here on Wikipedia. There is this chart that probably talks about. So you should read that on Wikipedia, but the idea is most of these tools do pretty much the same concept. Concept is that you have to define your desired state. And then put that in writing in form of code of some sorts, and then run off the code. So you modify your cloud infrastructure, modify your application settings, modify whatever you want in the context of what you want to deliver to the customer, but do that strictly with the discipline of maintaining your desired state in your code repository. So most older days, like, you know, we used to have, the developers will create their applications and then they will throw it off to the test people. The test people will take it and find bugs and throw it back to the developers. And this cycle will go on for some time. And then at some point, they'll say, it looks like good to me. So they throw it off to the IT operations people who will then run the link service or the Skype for Business service, for example. And those service people will say, you know what, this thing doesn't work for our infrastructure, give it back to you. And this handoff game goes on and on and on. This is happening primarily because the operations people and the test people and the development people don't work off of the same set of infrastructure design. The design that your operations people have, the design that your development team has is completely different. This is IT operations running link service, which is now known as Skype for Business service. And your developers are running your own development. And so they are not coordinating their efforts, and the designs that they are working with are completely different, or maybe somewhat different. Even if it is tiny little different, it may or may not work. So there comes this other systemic problem, which is known as, it works on my machine. Why does it not work with your machine? You've seen this before. It works on my machine. What's wrong with you? So it's a blame problem. So the blame is suddenly shifted from my machine or your machine to you. What's wrong with you as a person, as if something is wrong with the person. But you've seen this. It works. The piece of software that I develop works on my laptop, doesn't work on your computer. Something is wrong with you because it works on mine, right? That's the problem. That is the frame of thinking you have to break. You can break that way of thinking by putting every single thing about the runtime environment of your application in the context of in the discipline of a Git repository. And we'll do more of these probably next time. So we have shot over but we will take a break right now. We'll resume again at what time is it? Tuesday, which is 4th. So at 5 p.m. on 4th of October, we will resume and continue our discussion. But the core concept that I need you to take away is infrastructure as a code. Store everything you want to do, entire application infrastructure, the design, the application itself, the design for the infrastructure, the design for machines, the configuration of that, all of that, whatever you desire, you put that in code and then use it from that code repository in a Git repository typically, and apply that. That keeps everybody in synchronization, everybody in harmony, and that leads to this ultimate game that we want to accomplish, which is communication, collaboration, and continuous delivery of services to your customers without causing internal problems within the team members. So you basically cut down and retain the problems all within a Git repository and manage it carefully there. And you apply that to your cloud infrastructure so that the customers are not impacted. That's the core concept. We'll do exercises to apply these things in real life. There are a ton of exercises available here in this write-up. You will see them. There is way more content than you can actually fit into the hours that we have. But this is primarily for you to digest. We will kind of sort of broadly go along the sequence like you have here. Sometimes we'll go randomly in some context, but these are independent modules written in form of a sequence. So you should begin practicing, following along. Don't wait for us to actually cover. If you have time, proceed ahead. It doesn't hurt. So there's nothing wrong, nothing prevents you from using this content available here. Proceed. All of it is open and accessible to you. And as I said, I will keep it accessible to you until you need. So if you need more time, I will extend it. With that, I want to thank you. And I'll pause recording right now.
Thanks, Nilesh.
Thank you, sir. Thank you very much.
Thanks,
Happy
Nilesh.
Saturday, all.
Yep.
Thank you.
Yeah. Thanks, Nilesh. Have a good weekend.